So the next class in this chapter drying or the equipments that we are discussing drying dryers is about spray dryer and fluidized bed dryer. So we'll do these two equipments in the coming class. And then we'll also have to learn about freeze dryer, which we'll do it in the subsequent classes, right? So let me just start sharing the video. Now, the next equipment that we are trying to learn is a spray dryer. Spray dryer is a very common equipment used in almost drying all kinds of pharmaceutical materials. So, for example, to coat some, like lactose is spray dried. What else? Spray dried zinc oxide, calcium carbonate. Almost all the pharmaceutical equipments is dried using spray dryer. And spray drying is a method of producing a dry powder from a liquid or slurry. And it is by rapidly drying using a hot gas. This is the preferred method of drying for many heat sensitive pharmaceuticals. And principle is very simple here. It is the continuous transformation of feed from a fluid state into a dry particulate form by spraying the feed. You will almost spray the feed. Feed here is your solution or suspension in the form of tiny droplets by using an atomizer. Now this atomizer will spray your liquid in the form of a tiny droplet, and this tiny droplet, as soon as it comes in contact with a hot air environment, then droplet dries and forms a small particulate solid material which is completely dried, right? So the principle here is it is the continuous transformation of feed from fluid state to particulate form. And the feed is either solution, slurry, emulsion, gel, or paste. Now, this happens in 3 steps. Just write the steps in the principle. The first step is the atomization of liquid to form liquid droplets. Second step is the drying of liquid droplets. Third is the recovery of dried product. Now, coming to construction, many different types of spray dryers exist. But here we'll study this. It consists of a feeding pump. This is the feeding cup or feed pump, the pump which feeds the liquid, and then it consists of an atomizer, which is a very important uh, right, which is a very important part of the equipment. And then it also consists of a heater, air heater, which heats the equipment, air heater, air blower. There should also be an exhaust for removing the hot air or the moist air, which is completely saturated with moisture. You will have to keep removing it. And then comes a cyclone separator as a accessory at the end, right? Now, why is this cyclone separator here? Is to separate the sometimes air also escapes, fine particles also escape through the air. Now, to separate the fine particles, you use a cyclone separator. So only the moist air is removed by using an air exhaust, and cyclone separator separates the fines and then gives you the final product. So coming back to the parts or construction, it consists of a large cylindrical drying chamber. The chamber that you see is a large cylindrical drying chamber with a short conical bottom, and the diameter can be 2.5 to 9 meters. Height can be 25 meters or more. An inlet is placed at the entrance for the hot air to come inside, and another inlet containing spray disc atomizer. This is an atomizer which is spray disc atomizer. Where there are also other atomizers, rotary atomizer, etc. But we use a spray disc atomizer. And bottom of the dryer is connected to a cyclone separator. I already told you the purpose. To separate the fine particles escaping along with moisture. And then it is a one-step continuous unit operation that employs liquid atomization. First step is the liquid atomization to form liquid droplets that are dried to individual particles. There are three stages that I told you, include atomization and then drying and recovery. During atomization, there is a nozzle or a rotary atomizer. Atomizer is very simple. The name itself says it will turn the liquid into an atom-sized droplets, very fine droplets. And that atom-sized droplets will turn the liquid feedstock into small liquid droplets. This is followed by separation of solute or suspension as a solid and the solvent into a vapor. And it is during this stage, these atom-sized droplets come into contact in all directions. They come into contact with the hot air, and then drying happens. Solids form as moisture quickly leaves the droplets. And then second step is the drying. Drying, as it happens like this, there is a liquid droplet. First, the moist air or the hot air, what does it do is it will form a thick wall as the first layer, exterior layer of the liquid droplet becomes hard, shell-like. There is water that is getting accumulated inside. So due to the osmotic pressure or the pressure differences, there is a burst of the droplet. When the droplet bursts, all the moisture evaporates, leaving behind your solid product. That is drying of liquid droplets. The last is the recovery of dried product. Recovery process takes few seconds. You can use a cyclone separator to recover the dried product. Now, advantages, it has ability to operate in aseptic pharmaceutical processing. It has few moving parts. So careful selection of these moving parts can result in a system having no corrosion. And it has ability to produce nearly spherical particles. As the droplet bursts, you will almost have nearly spherical particles with uniform drying. And main advantage with this is it is very rapid. Also, heat sensitive substances can be conveniently dried using spray dry. Disadvantage is it is a very bulky equipment, costly equipment. It needs material in liquid form. Sometimes all the materials cannot be in liquid form. So the product degradation can also be seen sometimes. Antibiotics, molds, or even your enzymes, vitamins, yeasts, vaccines. Vaccines are also dried using spray drying, please note. And you can also use this in non-pharmaceutical applications like soap industries, surfactant industries, vegetable, fruit, plant products, milk products, your Amul milk powder or everyday milk powder. The milk powder also comes by using spray drying, right? So the next equipment that we are learning is the fluidized bed dryer. The most hyped word is this fluidized word. That means it is highly efficient. Now, what is this fluidized motion? Is the suspended motion. If your particles are suspended in air like magic, right? When you maintain the velocity of air or air drag is greater than gravitational pull. When you maintain sufficient velocity of this hot air, all the particles remain suspended in this hot air, which is called fluidized motion. Now, what is this FBD, the commonly called fluidized bed dryer? Is a very well-known and widely used equipment in pharmaceutical manufacturing, used in granulation processes. And the principle is, it works on the principle of fluidization of feed material. Now, what happens in fluidization is hot air is introduced at high pressure through a perforated bed of solids. So when you introduce hot air from the under this perforated bed of solids, it will maintain this, the bed of solids uh, will be pushed upwards by this hot air and will be suspended in the hot air for sufficient period of time. And then this hot air is in contact with each and every particle, facilitating faster and efficient drying. So let me show you the equipment so that you understand. Now, also in the construction, it consists of a stainless steel chamber. This is all a stainless steel chamber, and having a removable. This is a removable and detachable bowl. As you can see, it is a detachable, removable bowl. Perforated base. The base is not solid; it is perforated. What is perforated is it is having holes, fine holes, so that air can pass through these from under it, right? And it consists of heaters here. Inlet is from here. Uh, Hot air from here is passed through these air heaters. Then it gets heated up, and the hot air is directed to the to the solids, to the bed of solids. Uh, and then you also have bag filters here. What is the purpose of bag filters? Is when they remain suspended in the air, sometimes very low dense particles, they don't fall back into the detachable ball. They go away with the circulation and can be escaped through the outlet. So what do we do is we put bag filters here to retain the fine particles from escaping into the environment. Now working is, as I told, material to be dried is placed in this detachable bowl which has perforated base. Air is introduced from the inlet, and the air is filtered through the filter. There are filters here which filter the air, and then the air passes through the heaters. Airflow is generated by the fans fitted at the top of the equipment, and the hot air, uh, as the flow of air increases, what does it do is it goes under the fluidized bed solids. It will maintain a sufficient air drag so that it is greater than that of velocity of air. Hot air is greater than that of gravitational pull, so it starts to rise up in turbulent motion. Fluidized bed dryer has and during this suspension in the air, each and every particle is individually dried up, leading to a particulate granular form, and it has high drying rate. Material is dried in a very short period of time. Advantages is low capital, low maintenance cost, but uh, high velocity, high pressure air has to be sent. So that becomes expensive, and you can write it in uh, disadvantage. It has no hot spots on the final products. It is suitable for both continuous and batch material processing. Highly efficient. Disadvantages is non-uniform product quality. Sometimes there is no quality of the product is not uniform, and high potential for attrition. Attrition is rubbing of particles takes place because of the turbulence that is created by the hot air. And the conventional hot air FBD is not a good choice of dryer when you're handling toxic or flammable solids, since there is a danger of fire or explosion of flammability uh, in this FBD. Sticky material can also be not dried in this FBD. There's one last equipment to be discussed in this chapter, which is the freeze dryer.